Hi there, we're going to have a look here at how to draw and work with cumulative frequency graphs. Generally, this is used for continuous data, but not always. But normally, it's going to be data that has been split into class intervals. So you can see here we've got weights going from 65 kilograms to 115 kilograms, and each class width is 5 kilograms all the way through. So as the name suggests, cumulative frequency means we're accumulating the frequency as we go along. We're adding up the frequencies as we go along. So we'll need to just work that out first of all. If we have a look at all of those, let's move that out of the way slightly. There we go. So what you can see is that to work out the CF, the cumulative frequency, I've started with a frequency of 1, then I've added on the 2, which gives me 3, then added on the 8 to give me 11, and so on and so forth, until I've basically got every single piece of data. So there must have been 80 people, or whatever it is, we don't know what's being surveyed here, but 80 sets of data here in total. And what you then do is plot that on a cumulative frequency graph. So with a cumulative frequency graph, I haven't labelled it, but it would be cumulative frequency always that goes up on the y-axis, and then whatever quantity is being measured, in this case weights, will go along the x-axis. And what you do when you plot the points is you plot your cumulative frequency against the end point of your class interval. So that's important to note. Unlike when we're estimating the mean, when we would use the midpoints, we're going to use the end points here. And the reason is, if I'm saying, for example, here that the cumulative frequency is 3, I know that I've got 3 bits of data by the time I reach 75 kilograms. I don't know that I've reached 3 in terms of my frequency if I went for the halfway point of 72.5. So we go for the end point every single time. If we look at what we would then plot, let's just get rid of that, you can see that we've got all of those points. So you can see, for example, 71 is this point down here, 75.3 is the next point along here, and then all of those points are joined together with a smooth curve, and it should be a curve that goes through every single point. It's not like a curve of best fit. It must go through all of the points and be smooth in the process. It shouldn't look like it's sort of straight lines, and you certainly wouldn't do it with a ruler. Once we've done that, we can then actually extract some useful information from this cumulative frequency graph, particularly the medians and the quartiles. And just notice as well the sort of shape that we get. Obviously, because it's cumulative frequency, this graph always has to go upwards. There's no way that it could ever come back down again. And generally, it has this kind of shape of an elongated S shape. The place on the cumulative frequency graph that's the steepest, so you could refer to it as the point of inflection, but the steepest place is basically where there's the highest amount of frequency. Where is the frequency increasing at its fastest rate? So generally that's going to be in the middle, but if you've got slightly unusual shape to your data, obviously then that could happen in different places. Also the rate at which it increases, if I have it very steep for quite a long, for sort of a very short duration, so it was really steep along here, then that would suggest that I have a low interquartile range. Here, if it's a bit more gradual, then I've got a higher interquartile range, so my data is more spread out as a result.